So for this video, we will start with talking about the obstacles and challenges, then we will continue with what we learned, and then segue into the design process.
What did you learn?
The big learning point for me was the concept of the skirt. I kind of had previous ideas of what a skirt would look like, but I never really knew how it worked or what its purpose was. I thought it was like structural, but it turns out it was not only structural for the hovercraft itself, but it was also it also provided all of the lift for the hovercraft, and if if the weight was balanced correctly, it also provided a load of propulsion as well.
How did you arrive at the final design?
It was a combination of things. The makerspace was a huge help. We were able to 3D print all of our most or all of our parts. It was also just the group was big in the sense that we worked well as a team. There was no tension whatsoever, and we got along very well. And I think that was huge because sometimes other groups can struggle with finding a rhythm and finding a team dynamic.
What sort of obstacles and struggles did you encounter?
The big struggle for us was the time constraint for what we were trying to accomplish. We were trying to build the biggest and fastest hovercraft, so we didn't really have. It was going to be, for what we were trying to accomplish. We didn't start soon enough, so we definitely started ahead. We started working on the project maybe like 1 or 2 weeks after it was signed, but for what we were trying to accomplish, it wasn't soon enough because we had the goal of being the ultimate winner, and in the end that was our downfall because we ended up struggling at the last minute to put something together.
How did you approach the problem at hand?
It was a combination of things. First, it was a lot of research on our part because we had ideas of what a hovercraft would look like, but we didn't actually know how it really worked or what the physics behind a hovercraft would look like, or how the lift would work, how the propulsion all fits together in one piece. And it was really it was just putting a lot of hard work into it and staying committed and not being distracted by other things.
Time and scheduling were our biggest issues. We had big ambitions for this project, and in the end, we were simply rushed to put out our best product. We went through many designs in order to arrive at our final design. First, we began with a very simple square design, incorporating just the main fan providing the lift. As each little step checked out, we continued in this fashion and incorporated more and more parts until we decided we needed an onboard power supply. AA batteries turned out to be very heavy and weighed the craft down and simply didn't give the motors the power required, which was roughly 40 watts. In the end, lithium polymer batteries provided the necessary power and weight requirements. With this substitution, we did sacrifice the watt-hour capability of the AA's for the greater discharge rate of the lipos. Constructing the final design proved to be quite challenging due to the lack of a viable control mechanism. This meant conducting trial and error tests in order to determine how much weight should go in a certain location on the hovercraft's base. Connecting the lithium polymer batteries to the circuit itself proved also to be quite dangerous, as potential arcing can occur if the two opposite leads of each of the two batteries came in contact with each other. Despite these challenges, in the end we were able to assemble a complete and working hovercraft that was safe and ready to use.
Buddy, you can do it. Give a little push.
What happened during the final test was that the lithium polymer batteries got too low due to improper balance charging. The voltage in one battery did not match the voltage in the other. This led to increased discharge rate in the other battery. This was indicated by a voltage tester placed on one of the batteries, which would sound an alarm if the voltage in one of the batteries got too low. This was an important lesson in how powerful lipos can be, and at the same time how fast they can really run out. To conclude, through this project we learned the three basic concepts of hovercrafts, including lift, thrust, and structure, the challenges involved in this undertaking, and most importantly, implementation and engineering design process, and how that contributes to a complete design.